I was in graduate school with a friend of mine in Northern California, and we were in engineering school considering very kind of technical challenges in grad school, and in our free time we wanted to solve problems that were a bit more creative. And he had a wedding coming up, probably 4 months down the road, and really wanted to create his own wedding chandelier. So he began building this chandelier in the living room, and it was 6 foot tall and 6 foot in diameter, and made up of just these little strips. These are becoming more and more prevalent, but they're little addressable LEDs. You see them all over the place, and you can control them with Arduinos. And so he created this chandelier for his wedding. I helped a little bit on this one. And then over time, I became more and more enamored with the idea of creating a structure that used these addressable LEDs to to mimic mathematical functions or natural phenomena in the world. So I'm going to plug this in, but this is effectively the third iteration of this chandelier project that my roommate and I were working on in Northern California. Let's see if this is going to work. Power on. Oh, did I just kill it? Okay, it'll start. So this animation is each strand is mathematically modeled as a pendulum. So its velocity varies over the arc of its swing, and each strand is a pendulum of a different length. So what you'll see here is this strand is a slightly shorter length, and it goes at a faster rate than its neighbors. And so over time, they start to spread apart. You get this aliasing chaotic effect as the repetitious patterns harmonically oscillate, and then they come all back together in sync with one another. So this is just the beginning of this pendulum animation. And then what you'll also notice is all of the white speckles that you see, those stars, are responding to the sound of my voice. They have a memory. I have a microphone inside that has a memory of the loudest amplitude sound that it's heard over the last, well, infinite duration. But its memory decays logarithmically. So as time goes on, it forgets the loudest sound that it's heard. And so if you're playing music, it will be reintroduced to this high amplitude sound, and then at the crescendo it will be peaking with all of its twinkles, and then when it calms down again, it will logarithmically forget the loudest sound, and it will decay off and then start to respond to lower amplitude sounds. But this is one animation that I've written, and then I don't have it set up yet, but let me see. I have a Bluetooth transponder in here that allows me to change its animations, and I should have done this ahead of time, but here we go. Yeah. Thank you. Just pay attention to the orb.
What's the microcontroller you're using?
I'm using a Teensy, which is an Arduino architecture, but it has a lot more processing power and memory. I haven't done this in a while, so. What Teensy? I think it's the 3.2, version 3.2. Here we go. What other? The Bluetooth module is just a Bluetooth module that I got on Adafruit. I haven't worked on this in probably a year, so I've forgotten a bunch of the details. But this is the pendulum animation that I have. I have, spectrum analyzer animation. This is also sound responsive.
Rainbow fade, rainbow fade.
This is also sound responsive, and it's great with music. Laurel, Yanny.
Laurel. Have you guys seen the New York Times visualizer of that? It's really good. You can scroll between the two.
Oh, really?
It's amazing. Incredible.
So raise your hand if you're Yang.
Well, it depends on your speakers. It's all depends on.
Raise your hand if you use earbuds.
Yeah.
But I was in a room with people. We were listening to the same speakers.
Well, yeah. So it is different for different people, but it's very dependent on your speakers. Because it's frequency and frequency.
Alright guys, look, this is not that talk.
I've heard multiple people in the same room say different things, though. It's all about your ability to hear different frequencies, no?
You can scroll it back and forth, and if you try with earbuds, you'll get a different scroll point.
Yeah. I can see it. Okay. Yeah. It would be interesting to know how this would respond to that. Yanny versus Laurel. You'd probably respond to both. It's got a favorite, I'm sure. There are a number of animations from a simple twinkling animation. This is just populates all of the, it stochastically populates illumination points around the surface of the sphere, and then it decays them also logarithmically, much in the same way as you saw before. I have, cover your eyes, this is going to be bright.
What's the power draw on this full range?
Yeah, so that was also part of what I really loved about this project is I embedded everything inside. So this just has the 110 volts coming in, and then it's got a power supply internally that converts it to 5 volts, and then feeds a power bus for the Arduino, for the Bluetooth module, for the microphone, and then obviously for the addressable strips.
What's the power draw?
Power draw, this can peak at 200 watts. Everything is full white, but nominally this consumes probably about 50 watts on its
That's a big power supply.
Yeah, 20 amp power supply.
Yeah, exactly. And that's hidden inside of a repeating structure. Internally. So the first iteration, like I said, was this 6 foot tall, 6 foot wide chandelier that was just the strips, and it was a classic chandelier shape that started at the top and it had this large pear bottom to it. But after transporting it to different venues, the strips started to get warped and twisted, and it would show different lights in different directions. And I really wanted something that would have a consistent structure to it. So through the second iteration, and then now to this third iteration, I implemented this orb structure, this ellipsoid structure, which is fundamentally, mathematically, purely just an ellipsoid. And it, what is it, 2,400 LEDs that are on this structure. But I modeled this in Fusion 360 and made it a parametric ellipsoid with any number of horizontal slats that you can outline in the parameters. And it'll automatically modify the height and width of that ellipsoid and then repopulate these rib structures horizontally. So really, I can shrink this down to be a small lamp that can sit on your desk, all the way up to a huge, again, a 6 foot by 6 foot sphere if I wanted. I can change the mathematical parameters and make it a really wide ellipsoid or a perfect sphere or a long, tall one like you're seeing here.
Is part of the math having it hit right where the LED breaks are?
Correct, yeah. That's also in the parametric model, is to just have the spacing set so that the LEDs are always supported structurally in the same way. And if you look closely, they're retained within little laser cut sections in order to constrain the mechanical structure as well.
Is there any other fastener? Is it just the wood sandwiches holding
Yeah, these are captured nuts. Tuna fish fasteners, what did you say?
He's asking
Oh.
you to repeat my question because I'm not holding the fish. You're not holding the fish?
Oh, his question was what holds it together? And these are machine screws. They're M3s that have a captured nut mechanism inside. So the nut is retained in a cutout in the plywood and then purely just preloaded through that machine screw. And those are at each of these joints. Also, the wiring is retained in small notches on the inside of the vertical spars. I split out the power bus from the 5-volt supply and ran it down again with cable that is notched within the spars, so it's not just free hanging in the structure. But you're welcome to come and check it out. Yeah, question.
How do I buy one?
I would love to sell you one. Right now, this is the only one in existence. I was talking with someone who has a laser cutter because realistically, that's like the biggest hurdle in my mind right now is to just get a laser cutter that can pump these things out. And then I've got the bill of materials laid out to just place Amazon orders or orders from China for suppliers. So. I definitely.
What do you think you'd sell them for if you semi-mass produced them?
What would I say for a dollar amount?
Yeah.
Oh, I don't think you're gonna like that number. I don't have a number that I can say like officially, but I've put personally about $6,000 into this. And that's not just in materials, that's also in time, in the design process and in the iterations that have gone through it. So I would need to sell above that. That's true, that's true. We can talk about business models. We can talk about business models all day, and the toy guy is here, so he knows a lot about that.
So we'll save that for the break. We're out of time for this, but give it up for Martin.
Thank you. Thank you. Awesome.